Okay, so here is the review video that can help you if you're still having a hard time writing equations and then coming up with some identifiable parts for parabolas and for quadratic equations. And we're going to start off with just a given point, which is my vertex, and then some secondary point that I'm going to be able to use to come up with an equation. As you can see, I'm giving you guys that if you are starting with a vertex and you are starting with the second point, what you should do is you should be utilizing your vertex form. That's going to help you write equations for parabolas if that's the only information that you have to go off of. What I want to be able to do is I want to be able to take my vertex, which is the h and k that I'm used to, and I want to take some secondary point, which is the x and y, and plug all of this information in and solve for the a value that I have in my equation. So I'm going to drop all of that stuff in and then just see what I get. So at this point, I'm going to plug my y value in for y, which is a -5, and that's going to be equal to my a value, which is what I'm trying to find, times my x value minus my h value. That's still squared, and then my k value in this case is a -9. At this point, I need to simplify this down and then solve for my a. If I'm simplifying, I'm going forwards through PEMDAS, which means I'm going to do what's in my parentheses first. So this is going to end up being a -5 is equal to a times a -2 squared minus 9. A -2 squared is a 4, so this is really a -5 is equal to a times 4 minus 9. And we usually don't write a times 4. We usually write 4a. So I'm just going to swap that around. It's still a -9, and it's still equal to a -5. That's as far as I can simplify this. At this point, I need to start solving for a. Now I'm going backwards through PEMDAS and undoing math. Well, I need to undo this -9. I'm going to do that by adding 9 to both sides. And this will be canceled out. I'll have a 4a is equal to 4. And then the last step to getting a by itself, divide by 4, and a is equal to 1. Now, that's the a value in vertex form. But I'm not in vertex form yet. I still need to plug back in the a, the h, and the k in order to be in vertex form all the way. So my final answer when I'm in vertex form is going to be y is equal to my a value, which is 1, times x minus my h value squared, and then with my k. And this is vertex form. That sounds awesome. The next thing that I want you to be able to do with this is I want you to be able to take this information and I want you to convert it over into standard form. In standard form, you guys have this one right here. In standard form, I don't have my parentheses anymore. What I need to be able to do is get rid of them by foiling all of this stuff out. So what I'm going to do is I'm going to take my equation that's in vertex form right here, and I'm going to rewrite it without this exponent that's right here. So I'm going to take this, y is equal to 1, and now instead of x minus 1 squared, I'm going to put in x minus 1 times itself, because that's what x minus 1 squared is. And then I still have the -9. What I need to do, guys, is I need to go through and multiply this part first. Once I do that and simplify it, then I can worry about going through and multiplying the stuff on the outside and adding and subtracting the stuff on the outside. But I want to tackle the inside part first. So this is going to be y is equal to 1. And then I'm going to multiply by doing my distributive property. X times x is x squared. X times a -1, minus 1x. Minus 1 times x, minus another x. Minus 1 times a -1 is a +1. And then I still have the -9 on the outside. Now I simplify by combining like terms. And then I continue by multiplying all of my stuff on the outside by all of the stuff on the inside. In this case, it's just a 1, so nothing changes. And then the last piece is I'm going to combine my like terms there. So I don't have any parentheses left. I can do that. And my equation is going to be y is equal to x squared minus 2x minus 8. Awesome. So now I've got two different versions of an equation. I have this one here, which is my vertex form, and this one here, which is my standard form. And I'm going to actually use those two pieces of information to find some other things that I need. So we're going to take our vertex form and our standard form, and we're going to go through and we're going to find all of this stuff right here. Notice I still have my vertex form right here. I still have my standard form. I'm sorry, other way around. I still have my standard form right there and my vertex form right here. And I'm going to go through and find all of the other little pieces that I need. The first thing that I want to do is find my solutions. The way that I'm going to find my solutions is by factoring down and then setting my factors equal to 0 from my standard form equation. So if I take my standard form equation, which is y is equal to x squared minus 2x minus 8, and I factor this thing and then set the factors to 0, I'll have my solutions. All right, so I'm going to do, since I have a quadratic trinomial, I'll take my a term times my c term. That's going to be 1 times 8. I'm sorry, negative 8. And that's going to end up being a negative 8. And now I need to find the factors of a negative 8 that are going to add up to my b term, which is negative 2. In this particular case, that's going to end up being a minus 4 and a positive 2. So my equation is going to factor to y is equal to x minus 4 and x plus 2, because it was a negative 4 and a positive 2. And then I take each factor, set it equal to 0, and solve. That's one of my solutions. And there's my other solution. My x or my y-intercept, I don't really need to do a whole lot with, because when I have my equation in standard form, which I do already, the last term is my y-intercept. So my y-intercept is going to occur when I have a point at 0 over and 8 down. I don't need to do any calculations to find that. It's just given to me, and that's it. My domain for this is always going to be the same thing. My domain for this is always all real numbers, or a negative infinity to a positive infinity in interval notation. My range is going to be based off of my vertex. My vertex, again, I already know. When I'm in my vertex form, the h value, that's this part, and the k value are going to be the vertex. So the vertex is going to be in this spot. My vertex is at 1 over and 9 down. So I'm going to use that vertex to find my range. I'm at 1 over, 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my point. I'm going to either go from that point up to a positive infinity for forever, or down to a negative infinity for forever. And I need to be able to identify where I'm going in my graph. So what I am going to look for is the value that I have for my a. This value right here, that a value is positive, so when I'm at 1 over 9 down, I'm going to start at that point, and I'm going to go up to infinity for forever because it is positive. So it's a positive value. That means that I'm going to start at a negative 9 in my y's and go to a positive infinity all the way through. That value also, because it's going to start at that and go upwards, is going to be considered a minimum value, and the minimum value is my vertex, so it's going to be at 1, negative 9. Now, I have my vertex already put down, and then all I need to do is put down some other points that I know are going to be there. I also know that my y-intercept is going to be at a -8, and that's at 0 over -8. That's going to be this spot right there. I know because of symmetry, I'm also going to have a point right there. So I'm already starting off with a little bit of my U-shape. And then I know my solutions in this case too. I have a solution at x equals 4. So I'm going to have an x-intercept at 4 over 0 up. So 1, 2, 3, 4, that point right there. And I'm going to have an x-intercept right here at a -2. So at -2 over 0 up. And this thing is going to be symmetrical. So all I need to do is sketch a graph using those points. And I'm done. I know this video is a little bit long, but I hope it helps. Keep practicing, keep working. I'll see you in school.